Okay, so yesterday we talked about vectors and scalars. Which of the two is more of a pain in the booty? Vectors, for sure. And there's tricky terms where it's not really clear which one is vector and which one's scalar. A lot of measurements it's clear. Time is definitely scalar. Area is definitely scalar. You can't put a direction on area or volume. You can't put a direction on temperature. Force would definitely be vector. A force is a push or a pull. So if you're pushing something, does it make sense that there's a direction? Yeah, if you're pushing something or pulling something, there's going to be a direction. We said acceleration. Acceleration has a direction. Is it accelerating to the left, to the right, up, down? There's going to be a direction there. And then we talked yesterday about two terms that are similar in meaning, but one is vector and one scalar, and that was distance and displacement. Distance and displacement are very similar, but one is vector and the other one is scalar. And like I said, vectors will always make your life more difficult, definitely. So you got to really be on your toes when you're dealing with vector quantities. Okay, so here we have velocity and speed, and this is super easy to remember. One is vector and the other one's scalar. Guess which one's vector? Velocity. It's easy to remember because it starts with V. V for vector, and then speed is scalar. S for scalar. Okay, so the definition for velocity. Oh, and see this little line above? See this right here? See the little bar above the V? Not an arrow. If it were an arrow, that indicates vector. But if you see a little line above a symbol like that, it indicates. If it were an arrow, that would indicate vector. But if it's just a line, that indicates average, the average velocity. And all averages is over a period of time. So like the opposite of average velocity is instantaneous velocity. And you'll see these terms in the homework set and on quizzes and on the AP test. A question could ask about the average velocity of an object or the instantaneous velocity of an object. A way to think of it, when you're driving your car, if you look at the speedometer is telling you your instantaneous speed, right? And if you add a direction, you could call it the instantaneous velocity. So how fast you're going at a specific moment is your instantaneous velocity. If you're talking about your velocity from one point to another point, then that's called the average, And a time interval, a significant time interval, could be as small as 1 second. A lot can happen in a second. Like if I take this pen right here and drop it, it hits the floor within about a second, right? What's the starting velocity of the pen? 0. So within a second, in 1 second, the pen goes from rest, 0 meter per second, to about 10 meter per second in 1 second. So, a lot can happen in small time intervals, okay? All right, so velocity. Now notice that velocity, what's this delta x here? We talked about that yesterday. That's change in position, also called displacement. So notice our vector term here, velocity, the vector term has a vector value within the definition. All right, and then speed is our scalar. And then over here, notice that speed uses what? Distance, which is also scalar. Okay, so let's just do an example. Velocity and speed. So we have this diagram again. So let's focus on A. So the car starts right here at point A, where the position, X is position 30 meters. And we're going to go A to F. So F is over here. So the position at F is negative 50 meters. And then let's just say that the time interval from A to F, I'm going to do a real easy one. Let's say it's 10 seconds. So that's a given. All right, so that's our situation. Let's figure out the average velocity from A to F. Okay, so it's going to be displacement over time, and the time is given as 10 seconds. Now, displacement is always final position minus initial position. So what's the final position for A to F? Negative 50, and then minus, right, minus the initial, which is 30. So it's negative 50 minus 30, which comes out as negative 80. So this gives us an average velocity of negative 8 meter per second. That would be the average velocity from A to F. Now, does the negative mean, is it telling us less than 0? No. What's the negative telling us? To the left. It's telling us the direction. So it's like this way is plus, and then to the left, to the right is plus, to the left is minus. That's our sign convention here. So the average velocity from A to F is towards the left because the displacement was towards the left. Now, just so you can see how tricky physics can be, let's now do the speed for A to F. It's going to be a different answer. It won't be the same answer because speed uses distance. All right, so speed is equal to distance over time. The time is still 10 seconds. Am I going too fast? No? Okay, the distance from A to F. So remember, the car starts at A, goes out to B, turns around, and goes back to there. So what's the distance from A out to B? 20. And then what's the distance from B all the way over to F? 100. So what was the total distance? 120. So this comes out as 12 meter per second. And you don't have to say plus or minus because speed is scalar and doesn't have a direction. You can't go negative speed. Yo.
Are we going to A, B, C, D, E, F? Is that how we do it?
We could have. I just picked 2 points randomly, so we didn't concern ourselves with B, C, D, or E. But on a quiz, if I gave you this diagram on a quiz, I could have said find the average velocity from C to E or A to D. I could have picked 2 different points.
But then we go to every single letter between.
No. Well, if we're focusing here on A to F, if we're focusing on A to F, we don't care about B and C. I mean, I guess we did for the distance, because for the distance, we have to factor in that it did go to B and then turned around at that point. Does that make sense? But yeah, if you're doing displacement, if you're finding the displacement, we don't care about this part of the journey from A to B. Only for distance, because distance factors in the whole length covered. Do you guys get this? Okay. All right, that's it for today.